Hi, my name is Zoe, and I'm going to be doing a quick review on rates of change in natural and social sciences. I'm going to be using the AP Calculus AB 2004 FRQ, Question 1, letters B and D. The problem starts, traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by f of t is equal to 82 plus 4 sine t over 2 in the interval 0 to 30 minutes, where f of t is measured in cars per minute and t is measured in minutes. We are going to start with letter B. Is the traffic flow increasing or decreasing at t equals 7? Give a reason for your answer. Since the question is looking for the rate of change of the traffic flow, then we're going to find f prime of t. To do that, you use your derivative rules, so you know that it is 0 plus 4 cosine t over 2, and then we have to use the chain rule, times 1/2. That then comes out to be 2 cosine t over 2. Then if we plug in 7 to that equation, we will have 2 cosine 7 over 2. Just a quick reminder that when you're using your calculator for these types of problems, your calculator should be in radians. And you can use the sine, cosine, and tangent functions, and then plug in, for this example, you can plug in 2 cosine 7 divided by 2, and that will give us our answer, negative 1.87. Now we found the rate of change of the traffic flow at 7 minutes, and since it is negative, that means that the traffic flow is decreasing at 7 minutes. So then we can say the traffic flow is decreasing because f prime of 7 is less than 0. Now we're going to move on to letter D. The question asks, what is the average rate of change of the traffic flow over the time interval 10 minutes to 15 minutes? Indicate units of measure. Since we're looking for the average rate of change, we can just use the formula f of b minus f of a all over b minus a. So we can plug that in as f of 15 minus f of 10 all over 15 minus 10. If we plug in our inputs, we will get about 85.8 minus 78.2 all over 5, roughly. If we solve this, we get that the average rate of change is 1.52. And we can't forget units, so we have to say cars per minute squared, since it's the average rate of change of f of t. I'm now going to be moving on to the 2012 AP Calculus AB FRQ question 6, and we're going to be doing letter C. The question asks, for the time interval 0 to 12 seconds, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t is equal to cosine pi over 6t. So, for C, it says, find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. It's very helpful to remember that the velocity of something is equal to the derivative of its position function, and the acceleration of something is equal to the derivative of its velocity function. So if we're given our v of t equation, and we're looking for the acceleration, then we're going to be looking for v prime of t, which will be negative sine pi over 6t, and since we have to use the chain rule, times pi over 6. So now we're looking for a of 4, which will be equal to negative sine 4 pi over 6 times pi over 6. If we plug that into our calculator, we're going to get negative 0.45. But what's really important about this is that it is negative. So the acceleration at this time is less than 0. Now we're going to check the velocity. So the velocity at time 4 is equal to cosine 4 pi over 6. And if we plug that into our calculator, we're going to get negative 0.5, which is also negative, meaning that the velocity at time 4 is also less than 0. With these results, we can say the speed at time t equals 4 is increasing, because v of 4 and a of 4 have the same signs. What this means is that if a of 4 and v of 4 are both negative or both positive, then our particle is speeding up. But if they're opposite, then the particle is slowing down.